Hello, my lovely students. Today I'm going to show you a really quick tutorial how to deal with polyatomic compounds. And so last time what we talked about is we talked about ionic compounds being the combination of a metal and a nonmetal. And we also described where on the periodic table we could find those. The other way that we describe these is we describe them as the combination of a cation, which is something that has a positive charge, and an anion. And today, this will be a bit of a better description than the metal versus nonmetal, because we are going to deal with something called polyatomic compounds. In terms of the definitions you need to know. A monatomic compound. Mono is Greek, and that means that there is one atom in some sort of charge. If we have something that is polyatomic, which is what we'll focus on today, that just means that there is more than one atom. So we are going to be dealing with things from our data table here that have more than one atom associated with a charge. So an example, a really great example of that would be carbonate. Another good example, there's only one on this cation side, that would be ammonium. All of these top ones here, these are all great examples of polyatomic atoms. And kind of the key with them here, so an example of a polyatomic atom would be carbonate. So our example is carbonate, which is a CO3 with a 2- charge. Now this 2- charge isn't stringent on either the oxygen or the carbon, but on the combination of all of them. So this polyatomic atom has one carbon atom and 3 oxygen atoms. And that entire thing has a 2- charge. So when we're dealing with this, when we're dealing with these types of compounds here, when we have to actually match them up with a metal is where this becomes interesting. So let's make something with sodium. I know that sodium has a positive charge, and then let's combine that with carbonate, which we just used. CO3 with a 2-. And so the formal name of this, again, ionic compounds, really easy to name. The formal name would be sodium carbonate. And if we were to swap and drop these, what I would do is I would take this plus charge and this 2- charge, and I would swap those. You actually do not ever want to touch the 3 that is present right here. You don't want to ever touch this 3 because what that is communicating is that there's 1 carbon and 3 oxygens. That doesn't have anything to do with the -2 charge at all. It is creating the -2 charge, but it doesn't impact how these two, this cation and this anion, are going to bond together. So when we swap and drop those, you're going to end up with Na, and then that little 2 will come as a subscript beside the Na. And then we have a +1, and we said that chemists were lazy and don't actually write the +1. If we wanted to be really picky, we could put brackets around this and say that there is one of this entire carbonate. When we look at our second example here, we'll look at one where this won't be a 1, and so we can't just ignore it. And we'll need to put brackets around that polyatomic ion to show that there are 2 of that entire thing. So in this overall compound, we have 2 sodium atoms, we have 1 carbon atom, and we have 3 oxygen atoms. And that is the swapped and dropped version. That's what sodium carbonate looks like. Now, if we were to do one more example, let's choose calcium. Which I know has a +2 charge. And then let's choose phosphate. Let's choose phosphate, which is PO4 with a 3- charge. Again, both of these can be found on our little data table where we have calcium over on the left-hand side over here with a +2 charge, and we have phosphate down here with the PO4 3- charge. And so when I am dealing with these two, again, I will want to swap and drop these 2 charges, leaving the 4, which communicates that there are 4 oxygen atoms. That 3- will come down here and lose its negative charge, and that 2+ will come all the way down here and lose its positive charge. what we will end up with then is we will end up with Ca3. And then this PO4, that is, you can think of that as like one whole fist. So if we need to have two of that whole fist, we need to multiply the entire thing by 2. And so what I'm going to do is something that you've probably been learning in math recently, is you're going to put brackets around it and put the little 2 on the outside. Yes, you can have 2 of these subscripts beside each other, but you will always need to have brackets. And so what this then has, what calcium phosphate has, is calcium phosphate has 3 calcium atoms. And in terms of when we're figuring out how many atoms of phosphorus and oxygen we have, we would need to quote unquote FOIL this out. So you would have 2 of this entire thing, meaning you have 2 phosphorus atoms. And you would also have 2 times 4, you would have 8 oxygen atoms. So that's how you deal with polyatomic compounds. Hopefully that was helpful and a really short, quick tutorial how to use them.